Yo everyone, welcome to another video. Today we are going to build a new JavaScript project. Let me show you what we are building today. Basically it's a video chat app similar to Omegle, Azar and Ola. The idea is a user connects to the app and he can video chat with another random user. Let's do a quick demonstration. Here I have two browser windows which should simulate two users. The first one opens the app and clicks on Start Call button, and it will try to connect to the backend server using WebSockets, and then it will start searching for an available user, and of course since no user is connected, it will just put the current user on a waiting queue. Now for the other user, when he or she connects to the app and clicks the Start Call button, it will do the same process again, but this time there is an available user on the queue waiting, so a matchmaking will happen, and finally a room will be created and the two users will be automatically joined and start a video chat. The dev stack of the app looks like this. For the front end, we're gonna use NextJs with Tailwind and ShadCN, and also I will show you a package that I created myself to add those beautiful animated emojis to the project. For the back end, we're gonna use NestJs and connect the back end with our front end using WebSockets rather than HTTP REST API. For the video call, it's not easy to implement that from scratch. You need to have a good understanding of WebRTC and more stuff. So we're just gonna use a third-party service that will handle that for us, and it's ZEGOCLOUD. ZEGOCLOUD is a platform that helps developers build real-time communication features into their apps. They offer pre-built UI kits, which are like building blocks with code for features like video calls, live streaming, and chat. This saves developers time and money by letting them focus on their unique app features instead of writing basic communication code from scratch. You can customize these UI kits to match the look and feel of your app. And the last part will be the database. Since we are working with queues, I think Redis is the best choice. We're gonna self-deploy Redis on a Docker container. Now, before jumping to VS Code, let me explain more the backend structure of our app and the logic that we'll implement. So here is the complete logic of the app. In one hand we have user 1, and in the other hand we have user 2. Each one of them connects to the app using a web browser. So far so good, but not both of them will connect at the same time, so one of them will be waiting for the other to join. Once the first user is connected, he should click on the Start Call button. This button will trigger a WebSocket connection to our NestJs backend. In our backend we have a WebSocket server running on a given port. When the request came from a client, it will trigger a NestJs service called find available user. So that's the first thing that will be executed. What does this service do is it checks on a database if there is an available user that our current user can connect with and start a video call. For the database, we are going to use Redis using a library called boolmq. After that, the output of the find available user should have only two options. Either a user was found or no user was found. In this case, since no user is available, it will trigger another service called register available user. Can you guess what this service do? Yes, you are right. It will add this current user in the Redis database. I will not say database, but the more appropriate term to use is queue. So now the backend for this user has ended. Our current user is on a queue waiting for someone to join. Let's move to user number 2. When the second user clicks on start call, the same process will happen again. The find available user service will be triggered, but this time there is an available user on the queue waiting, so the output of the service will be an available user. Now what to do? We have two users available. How can we connect them? Well, first thing first, let's remove the first user from the waiting queue, because he is no longer waiting for someone, and also to prevent a third user came and steal that user from user number 2 and crash our app. So a service called unregister available user will be triggered that will remove user number 1 from the queue. Now we have data of user 1 and data of user 2. All we need to do is create a room that will contain those two users, so a room URL should be generated. Okay, so here we have created this room object and add to it the two users and generated a unique ID for the room. Now, how can we send the room URL to the users? For the second user is easy. We didn't send him a response yet, so we send him the room data on the request response. But what about user number 1? That's why we used WebSockets and not HTTP REST API. We still have the socket ID stored in the user object, the one that we stored on Redis. And that's it. Both users have now the room URL. They can communicate. But wait a second, where is the code for video call connection? This process is not easy to implement. Likely we are gonna use ZEGOCLOUD, a third-party service that will handle that for us. It's very simple to use. We create a room ID and that's it. We send a request to ZEGOCLOUD and it will create and host and deploy the room for us just like that. So that's it for the logic of the app. Let's move now to VS Code to implement that. I opened VS Code and create two folders, one called front end and the other back end, and I also created this Docker compose file which contains the Redis container info. The content of the Docker compose file looks like this. For the services we have two. One is called Redis and the other one is Redis Insight, which is just an application to manage our Redis database from the browser. I gave each service a port and created a network so they can communicate with each other. And that's it for the Docker compose file. Now just run it by typing on your terminal the command docker compose app-d. After running the command you should see an output like this one. Now go ahead and create an empty NextJs project and an empty Nest project by running the two commands npx create next app and nest new. Let's start with the backend. Let's organize our code in a directory. So we are going to generate a module and a service that will contain all our methods. Open your terminal, make sure you are on the backend directory and run the command nest generate module call and also the command nest generate service call. And for the controller it's not required because we are not using HTTP REST API. Also we need to install some dependencies in order to create a WebSocket server. Run the command npm install nestjs/websockets and nestjs/platformsocket.io. By now your backend project should looks like this. Open your call service. It looks like this. Let's create a WebSocket server on this service. In order to do that, we need to add this WebSockets getaway decorator, and we need to supply this decorator with some parameters. The first one is required and it's the port. By default it's port 80, but I changed that to this custom port. The second parameter is just an optional parameters, of course, just to avoid any course problems with our front end. And that's it. it. Congratulations, you have successfully created a WebSocket server and ready to accept connections on this port. And how can we display a message to the console when a new WebSocket request was received? To do that, we need to point a WebSocket event to a method on our call service class. We create first the method that will handle that. Let's call it matchmaking, and inside of the method we add a simple console.log. And finally, we need to register a custom WebSocket event. And that's why we added this decorator here plus the name of the event. Now our server is ready to accept WebSocket connections and display this message for every new event. In order to test that, we need a WebSocket client. Let's create one in our NextJs frontend. In your terminal, switch to your frontend folder and run the command npm install socket io client. I have a button that will trigger this function when clicked. This function will first connect to a WebSocket server on this port. Once connected, this callback will be triggered, and finally this custom event will be sent. And just like that, we can now communicate between our front end and back end. Let's go back to the server side and implement the full logic of the app. Here is all the steps that our main service will do. First thing, it will display this message to the console, then it will create a user instance, then it will call a method called findAvailableUser, which will look for an available user on Redis. And then we will have two cases. Either a user was not found or a user was found. In case of a user found, we create a room and remove the found user from the queue. And finally, we send room data to users. We need to create types for TypeScript. Just copy those types in both front-end and back-end projects. Now, in order to work with Redis database, we should install some packages. Run the command npm install nestjs/bool. Bool is the middleman between Redis and NestJs. We need now to connect Redis. In order to do that, we need to edit the main app.module file. Inside imports, add this configuration and specify the host and port where your Redis instance is running. Cool, we have connected now our Redis database, but there is no queue. Let's create that. Open call.module file and add those settings to register a new queue. As you can see, I created two queues in here and each one has a unique name. Go back to the call service file and let's inject the dependencies. Your constructor should look like this. Let's create the methods now. We start with findAvailableUser method. First step is to check if there is an available user on the queue and do a check with an if statement. If there is a user, we retrieve the data of that user and return it. And the two other methods are unregisterAvailableUser that removes a given user from the queue, and registerAvailableUser that adds a given user to the queue. And finally, the initRoom method takes as arguments two params, the current user object and the available user object. It creates a room object and stores it to Redis. We add all those methods to the main service and we have finished our backend project. Now quickly move to NextJs frontend, open the page.tsx file, and what I did here is create a use state that can take some different steps, and based on each step we return a custom React component. For the connect function, it looks like this. First thing, it switched to the state of connection and tries to connect to our WebSocket server. If everything was gone correctly, it will switch to the state to connected and then send an event request. Also, I want to point that I added those sleep promises here just for better user experience, so the user can have time to see animations and what's going on. And finally, we get the room URL and redirect to the room. Open your terminal and install shadcn and also a package that I created to add some Logi animated emojis easily. For the components, I will not cover that. It's just JSX elements and Tailwind with animations. Just refer to the GitHub repo. Now, the last step before finishing is to create a custom page to handle that video call. Create a NextJs page and name it room, and for the content of this page can be found here on ZEGOCLOUD documentation. You need to change your API keys, go to ZEGOCLOUD, create an account. After a successful sign up, you will get a free 10,000 minutes on their services, which is very generous from ZEGOCLOUD's part. Once you are on the dashboard, click on create a project. On this list, choose voice and video call and click next. Choose a project name for your app. Scroll down and choose UI kits. Wait some seconds for the project to be created. After a project is created, you will see something like this. Since we are building a web app, click on web, scroll down and click on save, and there you go. You need to copy app ID and server secret. You need those two keys, paste them on the home page on NextJs. And that's it guys, we have finished our backend and front end and our app is ready. I hope you enjoyed the video. I don't know if you guys like this concept of going through the code very fast without too much details. Let me know what do you think in the comments. Thanks a lot guys, see you in another video.